Hello again, ladies and gentlemen. This is Dr. Robinson, and we're going to continue our studies. We are talking about compound inequalities. Our vocabulary. Let's make this full screen. All right. A linear inequality is one variable is an inequality of the first degree that contains only one variable. So since we're talking about a first degree, we're talking about to a power or exponent of 1. So that'll be the highest exponent in the inequality. For example, x minus 2 greater than 2x. Here's another inequality. 5x plus 2 not equal to 4. So notice the exponent is not written, so it's implied that it is 1. Here are your comparison symbols that you should go over. Make sure you make a note of them. Less than, there's the less than symbol. When you graph it, this is the open circle because you're not including the number, and here are the braces that you're using, the parentheses that you're using, which indicates the notation when we're dealing with the interval notation. So greater than symbol, here's your open circle and your parenthesis again for the interval notation. Less than or equal to, there's your symbol. When you use less than or equal to, you are including the number, and these brackets indicate that you are including the number as well. Greater than or equal to, here's your symbol, including the number. Notice it's a colored in circle, and it is using these two braces. The equal to symbol, you are equal, and you are using the circle, colored in circle, because you are including the number, and the braces again as well. The not equal to is a good one. We don't use that quite often, but you will be using that a little bit more. So notice in the not equal to, you're talking about open circle because you're not including the number, as well as not in your interval notation. Compound inequalities, that is when you're joining two or more inequalities with an or. So here's the symbol for an. It looks like the letter capital A without the bar in the middle. So that's the one way I tell my students to memorize it. This letter V is the symbol for or. So here's an example of how we use it. X less than 5 and x greater than or equal to negative 2 can be written as x less than 5 and the upside down V looking like the letter capital A, x greater than or equal to negative 2. As well as we can write it this way. Negative 2 is less than or equal to x, and x is less than 5. I tell my students, say it's between these two. So, and make sure you know that you're including. So, watch your comparison symbols. This compound inequality is true only if both inequalities are true. So when you're dealing with the letter and, the letter capital A without the symbol in the middle, it's true if both of the inequalities are true. So you need both parts to be true in order for your inequality to be true, your compound inequality. So let's take a look at that. Here we have those two inequalities. So I have the first part, x less than 5. I graphed it. Remember, open circle I use because we're not including the 5. And all the numbers going to the left towards the negative infinity are less than 5. Now let's graph the next part. X greater than or equal to negative 2. Notice we're using a closed circle. So closed circle at negative 2, greater than going to the right to positive infinity. So these two lines, so if we draw a little cut and we cut where they intersect, notice they cut right here on the negative 2. So the negative 2 is part of the numbers less than 5. and here it's equal to, and the greater than or equal to -2, so we're going to include that number. And on this cut here, numbers that are greater than -2, well, 5 is greater than -2, and we're cutting it because we're going to stop right here because we're saying greater than or equal to 5, but it has to be on this part less than 5. So notice we're not going to include the 5 because it's an open circle. So we want greater than or equal to, 5 is equal to 5, but we want less than 5. So that's why the circle is open, so we're not including it. So this intersection between these two cuts can be looked at right here, and we can draw a line indicating all the real numbers that are between -2 and equal to, that are less than -2 or equal to, and 5. So these numbers would be the solution set. So that's called the intersection of both of the graphs. Okay, let's move on. Where we have x greater than 4 or x less than or equal to 0 can be written as this: x greater than 4 with the v, which stands for or, x less than or equal to 0. So there's no shorter notation, unfortunately. This compound inequality contains the word or, so it's only true if one or more of the parts of the inequality are true. So you can have one part, the first part true, and the second part true, which is going to be fine. But as long as you have one part, you're in good shape. So the graph of the compound inequality is the union of the graphs of the two inequalities. So we're looking where there's a unity. So x greater than 4, so we're looking for that graph. So that was our first part of the inequality. So we open circle going towards positive infinity, and x less than or equal to 0. So we colored in circle because we're including 0, and that's going towards negative infinity. Here's where we're going to put the union of the two sets together. So when we have our compound probability, our compound inequality, the union of the two sets. So we graph the first one, x less than 0. So x less than 0. So notice it's going this way, and colored in circle. And x greater than 4, open circle because we're not including the 4. Notice it's going this way. Notice that there's no intersection like the other one where I would draw the lines covering or cutting both of these, but there's nothing that cuts in between them because they're pretty much going two distinct directions, different directions. So unfortunately there is no unity. So here's a question. Let's see if we can get it right. Identify the inequality from the graph below. So here I notice we have a colored in circle, so that means we have an equal sign. And here we have an open circle, that means we have no equal sign. So I'm going to look at this. There's no equal sign on the 6, good. And there's a colored in circle, so that means there's an equal sign. It starts at -3, x is in between, so A is good. And here's one way that I could write it. X is greater than, if I read it backwards, x is greater than -3, which is what B says. And I can read this half right here, x is less than 6. And that's what we have here. And together, we have this intersection. So there's a compound inequality where both of these are together connected. So B is also okay. So I'm going to say both A and B would be my answer. So my answer will be choice C. Here's one for you to try. Notice the circle's open, so figure it out. Check your understanding. If you're understanding what's going on so far, great. If you're not sure, watch the video again, write down your questions, and bring them to class. All right, let's graph x not equal to 1. I mentioned earlier we don't use not equal to most times, so the circle is the one we're going to put down on the 1. positive 1. And now we're going to get ourselves a line tool. So where's my line tool? And let me get a pointer. All right. So numbers not equal to 1. Well, 2, 3, 4, 5, 6. So all these numbers going this way are not equal to 1, as well as all the numbers going this way towards negative are not equal to 1. So we can keep going in both directions just as long as we don't step on the 1. So 1 will be not included in our set. So let's press. There's what it looks like, which is what we drew. Here's one for you. See if you can graph it. So good luck. Check your understanding. If you understand what's going on so far, great. If you're not sure, rewatch the video and write your questions. Here's an interesting question. So we want to find the solution set for x for this domain that they give us here. Then we have an equation of x of, when half x plus 4 greater than or equal to 4. So we got a multiple choice. We have the domain, that's the x values, for which are going to be replacing this set. So let's see what we're going to do. All right, so let us replace the x value with first -2. So 1/2 of -2. Half of -2 is -1. And now let's add to it 4 and see if it's greater than or equal to 4. So half of -2 was -1 plus 4. That gives us 3. Is 3 greater than 4? Nope. So that doesn't work. So let's get rid of -2 from the set. That one doesn't work. Let's try 0. So half of 0 plus 4, and see if that's greater than or equal to 4. Well, half of 0 is nothing. Plus 4, is that greater than or equal to 4? Well, 0 plus 4 is 4, and 4 is equal to 4, so this will work. So yay, we got one that works. Well, if 0 works, let's see if 2 will work. So 1/2 of 2. Half of 2 is 1. And we're going to add to it 4. And 4 plus 1, we're going to see, is this greater than or equal to 4? And it looks like it is. I'm seeing 4 plus 1 is 5. And 5 is greater than 4. And that works also. So yeah, we're checking each one. Well, I would think if 2 is going to work, then 3 should work also, because 3 is bigger the greater the number, so I assume it's going to also work. But I'll check it anyway just in case, because you never can be too sure on the regions. So check them if you'll have plenty of time. So check it out just to be certain. Half of 3. Let's erase that. Let's get my little eraser. Half of 3. Okay, half of 3. And let's see, plus 4 is greater than or equal to 4. Half of 3 is 1.5. Half of $3 is $1.50 plus 4. And I'm looking, yes, that definitely looks like it's greater than 4. 1.5 plus 4 is 5.5, and that is definitely greater than 4. So I would say definitely true. So the question is, which numbers in the domain work? Notice I put a check on the ones that did work, and I crossed out the one that did not work. So our answer is 0, 2, and 3. Those are the numbers that worked in this problem, and that's choice D. So here's one for you. See what the solution set of this inequality is. Check your understanding. I hope you understand what's going on. Here's a nice question. Solve it and see if you can graph it. All right, let's get into this last part of compound inequality. So here we have an inequality where we have -4 is less than, and we haven't seen this before, we have 3x minus 7. Usually we just have an x there, but now we have a little expression there. So less than 2. So how do we treat this? Well, we can do like we had in the beginning of our introduction. We have -4 less than 3x minus 7. And this is compound, so this is the letter A, and we have 3x minus 7 less than 2. So since we have two different compound inequalities, let's solve them by doing each one by themselves, and let's see if we can solve for x. So let's take the first one, 3x minus 7. So let me put plus 7 to both sides, getting my numbers over to the left. That way this will cancel out. I'll have 3x on this side less than, I cannot add these, I have to subtract. 7 minus 4 is 3. Choose the sign of the 7, it's positive. Now divide both sides by 3, and 3 divided by 3 is 1, less than, my 3's cancel out over here and give me the x. So my answer would be 1 is less than x, or I could write it backwards, x is greater than 1. There is half of my solution. Now let's deal with the other half. The other half was 3x minus 7 was less than 2. Let's add 7 to both sides, plus 7. The 7's will cancel out, leaving me with 3x less than 7 plus 2 is 9. Divide by 3, divide by 3, and the 3's will cancel out. I'll have x less than 3. And there is my other solution. So I solve my inequality, which is x is greater than 1, and the other half, x, is less than 3. So I can rewrite that as intersection, whereas I'll put x in the middle, and I'll put my symbols here, my less than symbols, and x was greater than 1, so 1 was a smaller number, so 1 is less than x, so I'll put that on the end here, but x was less than 3, so I'll put my 3 at the end here, and now I've written it as another way of the solution set. So we just found the solution set written both ways. Now I notice I wrote something in parentheses. Did I leave out something? Was there a equal to sign? Oh, no, there was no equal to sign, so let's get that out of there. So I don't want to leave anything that's not correct. So that should be greater than 1, not equal to. So let's fix this also. So it's not a bracket, so it's not equal to, so I wanted to put equal to, just to show you the bracket. So it's not including. So we're not including the 1. So our example was less less than. So not including the 1. And let's also fix this one. That was less than. Okay. So that was a good question. So hopefully you know how to solve it. Just be careful of your symbols, which one you're using. Don't do like Dr. Rob and write the wrong symbol. So check your understanding. I hope you understand. Here's a question for you. Oh, is x equal to, if x is x equal to part of the solution for the set of x greater than -3 and x less than 5? Well, if I put a 2 in here, 2 is greater than -3, that's true. And put a 2 here, 2 is less than 5, so I would say yes. And that's what I did. I just substituted to see if it's true and see if this one is true. And remember, we're using and in and, both parts must be true in order for our inequality to be true. So I'm going to say yes. So here's a question for you. See if you can do it. And check your understanding, of course. See if you understand. If you don't, watch the video again. Write down your questions. Here's some more questions for you. Determine if 1 is part of the solution set. Here's another one getting a little more challenging. So I hope you enjoyed the lesson and got something out of it. And remember, we're on YouTube, so check us out. My channel name is Dan Robinson. Check out our latest release, Math Prep 17, which is our newest release. We'll be looking forward to Math Prep 18. So watch us on YouTube. Write us, let us know how we're doing. Tweet us at drobmath1. And I hope you'll give us a thumbs up on YouTube because we are trying hard to get these study videos to help you out. So this is Dr. Robinson. I'll see you in class. Bye-bye.